All right, this is worksheet 23B. We're going to go over the application problems on Newton's law of cooling so that you will be able to do the packet. You can work on the packet tonight and we will work on it tomorrow in class, okay? If you can get it done by the end of class tomorrow, then you can turn it in and have no homework over break. All right? I am trying to get the final exam review packets, at least part of them, run for you by tomorrow. So if anybody cared about looking at what's going to be on the final, that would be available to you. But for now,
So what's
we're going to,
what's after this?
we will finish, when we come back, we will have one section left to cover on logarithms and regressions, and then we will review and test, and we will spend a few days on chapter 6, which is the basic trig stuff. Your right triangle trig, converting angles to radians, just some very basic stuff, okay? So we'll review the stuff you did last year, and or if you're in trig, then it should be really easy, okay? All right. Newton's law of cooling, guys. Newton's law of cooling is used to predict how long it will take something to cool to room temperature, okay? Or to cool to a certain temperature along the way. It does neglect or not take into consideration the idea that you could change the surrounding temperature. Okay, if I take a pizza out of the oven and set it on the counter, it really probably doesn't heat my kitchen up very much, right? It does heat the counter up, and it could change the temperature depending how big the kitchen is a little bit. Mostly it's the fact that the oven's been running that's probably going to change the temperature, not the pizza sitting on the counter. But if I take my coffee cup and fill it with cold water and take a hard-boiled egg out of boiling water and put it into this cold water, it is going to change the temperature of the water. Okay, so Newton's law kind of ignores that fact, and it assumes that the surroundings stay the same temperature. I just want you to be aware that it's kind of like when we say ignoring friction or something when we're doing physics stuff, okay? Not everything's going to be 100% accurate that we predict here. Newton's law says an object that has been heated will cool to the temperature of the medium in which it is placed. For example, the surrounding air or water. We are going to use this model down here, which says the difference between the temperature and the surroundings, the temperature that it stops cooling at or that we time it to, is equal to the difference between the original temperature and the surroundings times E to some constant cooling rate times the time, okay? We can use this formula if you want, and I would never ask this question on a test or quiz unless I gave you the formula, all right? But the idea is that here, like you took the pizza out, it's going to cool fairly quickly, and then eventually it's going to reach room temperature and stay there. Does the graph kind of make sense? All right, the first thing we have to do is check the temperature at some point to determine the cooling process or the cooling constant for an item. For example, on your packet, there's something about finding a dead body, like you would be a CSI, okay? And they give you the cooling constant, okay? But for our questions on this notes worksheet, you have to determine the cooling constant first and then plug it back in. So it says a cup of coffee we know has already cooled from 92 to 50 degrees after 12 minutes in a room that's 22 degrees Celsius. All right, can anybody determine which of those is the final temperature, the surroundings, or the original temperature, or the time?
92 is initial.
Okay, this is 22, which is the room temperature, which we're going to call the temperature of the surroundings. 92 was the initial. And 50? is the final temperature at least as far as in this 12-minute time period, right? So we're going to say the final temperature, which was 50, minus the surroundings, which are 22, has to equal the original temperature, 92, minus the surroundings of 22, times e to the negative constant that we don't know, times time, which is 12 minutes. All right, what's the algebra we need to do first? Do our subtracting here. I think I did that right. And I'm just going to call this negative 12k eventually. I guess for this one I'm not going to because I wrote it wrong. All right, what's the next algebra we can do? Okay. Which is what, 0.4 maybe? What? Should be 0.4, I think. What do we want to do next? Natural log of both sides. And then we'll have the natural log of 0.4 equals, if we bring this down out in front, negative 12k times the natural log of e, which is just 1. So the natural log of 0.4 divided by negative 12? That seems perfect to me. Did someone else get that? We did divide, this turned out negative, we divided by a negative 12, so the constant is positive. When we plug it back in, there's a negative in the formula, so it will continue to cool and be negative there. All right, how long will it take until the coffee's down to 30 degrees Celsius? Well, it doesn't say how much more time will it take, so we're going to go from the original when we took it out of the microwave or whatever, okay? So we're going to say I covered the formula up. The final temperature we want is going to be this 30. So we want it to still be 8 degrees warmer than the room, right? Which was at 22. I really have no concept of these Celsius temperatures. And the starting temperature was still 92. Yep, nope. I'm just making this all confusing. What do we need to be putting in here, guys? What are we looking for this time? T, yep. So we have negative 0.0764 as our K times T. So what algebra do we want to do first? Yep, we're going to divide and then take the log of both sides. Bring this out in front. Times the natural log of e, which is just 1. Yep, 28 point something, sounds right. Everybody get 28.4 minutes? It is a little bit complicated because you have to find the constant first. Example 2 makes me hungry. Okay, we take a nice warm cake out of the oven that was at 350 degrees. In 20 minutes it cools down to 120, but it's still too hot to frost, so we have to wait for it to cool a little bit further, down to 90. So what do we want to do? Anybody know where any of those numbers go?
120 goes in the T sub F. And T sub S should get 65.
Okay, the surrounding temperature would be 65.
So equal to 350 minus.
Yep, our original temperature was 350 of the oven,
Minus. Wait.
65 the surroundings. And how long did it take for that to happen? All right, can you guys work on the algebra, please? Anybody getting a constant?
I got
Mm,
0.0822.
I got, yeah, 2, 3 if I round to 4. Did you type 55 and 285? Can you look back and see? Did you subtract somewhere wrong?
359.65. Oh, I wrote it down wrong.
Easy to do. All right, can you figure out how long till we can frost this and eat it then? How long till it's down to 90? So instead of the final temperature being 120, we want it to be 90. And this time our K is negative .0, well, it becomes negative when we put it in, 0.0823, and we're looking for time. Brennan, are you getting an answer, or are you playing a game?
No, well, I wasn't playing, okay.
Noah, did you type something in or not?
Yeah.
What'd you get? Yep, so about roughly 30 minutes, right, till we can, from the time we take it out till it's down to that temperature. Whoops, that's not right. It's minutes, not degrees. So if we wanted to know how much longer we had to wait, we would subtract the 20 minutes that have already passed the first time around, and we'd say we got about 10 more minutes. All right, any questions on those? Just kind of complicated, not really hard, just a lot of steps, places to make a mistake. All right, this is the general half-life form. All right, we did some continuous decay with half-lives as well, but this is the general form. It says you take the original amount times 1/2 to the power of x is the time and h is the length of a half-life, and that will give you the present value, okay? So if we have radium-226, and that number is just part of the name, okay? its half-life is 1,600 years. Where's that gonna go? H is the length of the half-life, so that's gonna go here. Suppose we have a 120 milligram sample, how much will remain after 4,000 years? Where are those two numbers gonna go?
120 is gonna go into P sub 0.
Yep, this is gonna be the original amount, and this is gonna be our X value. We're just gonna type that in. So we're gonna do 120 times 1/2 to the power of 4,000 over 1,600.
Wait, what did you say?
Anyone else getting 21 point something?
21.21. 21.
Okay, how long till there will only be 10 milligrams remaining? Assuming we started with the same sample, and we're looking for the time it takes this time to get down to what?
The time.
Okay, so
Divide by 1.
divide. And then because x is in the exponent, we're gonna have to do what? Yep, take some kind of log of both sides, and it doesn't matter what kind, as long as you do the same one to both sides. 10 over 120 will reduce to 1/12, or you can leave it 10 over 120 until you type it in, doesn't matter. Now, can we just cancel the log of 1/2 this time? Like we've been doing with natural log of e? No, we have to divide it over there. So we're gonna do log of 1/12 divided by log of 1/2. And then we'll have to multiply by 1,600. Long time. Yep, to get rid of divided by 1,600, you have to multiply. Got 5,736 if I round to the nearest year.
I got 5,745.
I did not round along the way, so I literally typed log of 1/12 divided by log of 1/2 times 1,600. That's fine.
Wait,
Yep,
I
you'll get
got-
a little different answer if you round it along the way.
That's really, I got 400.
Did you close the parentheses here?
Oh, wait.
All right, what can I help you with? Questions? Otherwise, tonight you need to be working on that packet so that you can get that turned in and have no homework over break, okay? There is a regression problem I know we will do together tomorrow in the middle of the packet. Guys, I really wanted to go over questions first. Do you have no questions? Carrie? Shh, guys, please. What?
Are these questions from our homework?
Yes.
Oh, okay.
I'm willing to answer questions from the homework check for the next 8 or 10 minutes.
Number 5022A.
On 22A. All right. E to the x times e to the x would be like if I had this. How would that simplify? Okay, you add the exponents. So e to the x times e to the x is e to the 2x. Does that make sense? Caleb?
Yeah.
Okay. So this e to the 2x, I'm going to factor as an e to the x and an e to the x. Then I need factors of 130 that differ by 3. So I'm going to do 13 and 10. A positive 13 and a negative 10. So then I have e to the x equals negative 13 and e to the x equals 10 when I set them equal to 0. Does that seem okay? All right, but I still have not found x. What do I have to do to be able to find x? Yes, I have to take the log of both sides. Can I do the natural log of negative 13? Okay, so I get to throw that answer totally away. And here, I can bring this x out in front, and the natural log of e is just 1. So I have x equals the natural log of 10, or whatever decimal approximation that is, okay? You can leave it exact or give me a decimal, I don't care. Does that help? You know, I understand just factoring and then taking the log at the end. Brittany? Yes, it's log base 2 of m to the 4th equals 32. And that one, if you have a plus or minus at the end, because it starts out as an m to the 4th, you can keep the negatives. Okay, just think about that. Yes, somebody else? Carrie, did you figure out which one you had a question on? Okay. Anybody else have a question while I'm trying to open that one? Cody?
I'm thinking, 37 and 38.
Okay. Carrie, number 2? Okay. You just need to pick 2 numbers that multiply to make 6. Can you pick 2 numbers that multiply to make 6? 2 and 3. Okay. Can you try the log of 6 equal to the log of 2 plus the log of 3? Does that work? When you type that in? Natural log of 6. Okay, it's 1.79, and then if you do the natural log of 2, close parenthesis, plus the natural log of 3, close parenthesis. Anything else that works? Or that anything else that makes 6, I guess is what I should be asking. 6 and 1? Does 6 and 1 work? Yeah, it does. What else could multiply to make 6? 12 and 1/2. You could try 12 and 1/2. What did you say, Noah? Yeah, if you, it says up here they have to multiply to make 6. But if you did a negative 2 and a negative 3, they multiply to make 6, but you can't take the log of negative numbers, so there's 2 that don't work. Okay? So x could equal negative 2 and y could equal negative 3, etc. There's other possibilities, but okay. And what was the other question, Carrie?
5.
All right. If we were to take the log of both sides right here, we'd have this. Okay? It says to make ln of y into s. And what could we do here? This would be 2 times the natural log of x, right? And it says to replace the natural log of x with t. It's something you might have to do in calculus, some kind of trading out. Okay. Yeah, I'm not going to ask you that on a test or quiz. All right. Cody, worksheet 6B, is that where I'm looking maybe?
Yeah.
Is this it, 37 and 38 right there?
Yeah.
Okay. Number 37 says the half-life of a radioactive substance, and we're talking about one whose half-life is 704. So the formula we just used, where you take the original amount times 1/2 to the x over the length of the half-life, which I'm gonna leave 704 with a label of 1,000,000 because I don't want to type in all the zeros. So how many grams will remain after 1,000,000 years if you start with 200? So we're just doing 200 times 1/2 to the power of 1 divided by 704. Because it's 1,000,000 over 704 million. It's a lot remains. Almost 200 still remains. Okay? This is the same question except you just put in a 4540 for x, okay? Both of those were just typing questions. Can anybody help me set up 38 then? What does this mean, doubling time? Okay, so the original amount times 2, and it does it how often? So you would do every 12th day. Suppose a pasture contains 46 plants. How many plants will there be after 20, 65, or X days? Well, that's what you would write down for the X, but for the other two, you would just put in the value for X. Does that seem okay? We can finish those? One more question or not? All right, everybody want to tell Sierra happy Thanksgiving? Feel better, Sierra. Happy Thanksgiving.